Hello dear students, welcome to Konar classes. In this class we are going to discuss two questions on binomial theorem. Okay, so let me write down the first question and let me take it from my notebook. The question is that, find the rth term from the end in the expansion of x plus a power n. Okay, so generally dear students, what we have done that we found the r plus 1th term from the beginning, but here the question is that we need to find the rth term from the end. How to do that? So to perform that, let us first expand this x plus a power n. So if we expand x plus a power n, so what we get dear students? So I am expanding it elaborately. So the first term will be nc0 into x to the power n minus 0 into a to the power 0 plus nc1 into x to the power n minus 1 into a to the power 1 plus nc2 into x to the power n minus 2 into a to the power 2, and it will continue like this, and we will get the r plus 1th term from the beginning. As we are aware of, it is ncr into x to the power n minus r into a to the power r, plus it will continue again, and then you will get the last term, that is n plus 1th term from the beginning. Okay, so what will be the last term? If you recall, the last term is ncn into x to the power n minus n into a to the power n. When we say last term in general, that is last term from the beginning. But in this question, that last term from the beginning is nothing but the first term from the end. Correct? So now let us find a pattern first, that how to derive the rth term from the end. So this is the first term from the end. Then what will be the second term from the end? It will be something like this: n minus 1 into x to the power n minus 1 into a to the power n minus 1. Correct? Then what will be the third term from the end? Third term from the end will be something like this, that n minus 2 into x to the power n minus 2 into a to the power n minus 2. Correct? What will be the fourth term from the end? Fourth term from the end will be something like this, that n minus 3 into x to the power n minus 3 into a to the power n minus 3. Correct? So now if you notice it, that what is changing here dear students? The changing is that if it is n, then it becomes n minus n. If it is n minus 1, it is n minus 1, and here also a power n minus 1. So as it is changing, the power of x is also changing accordingly, and power of a is also changing accordingly. So our target should be that how we can make a pattern out of this n minus 1. Here in the third term from the end is n minus 2. Fourth term from the end is n minus 3. How we can find a pattern? Okay. Now to find a pattern, what we see dear students is that we can write this n as n minus 1 minus 1. you may have a question that, sir, how you are writing like this? Okay, because this 1 is associated with the first term from the end. Let's look at here that we can write n minus 1 as n minus 2 minus 1. And you see this 2 is associated with second term from the end. Look at n minus 2. Then what we write, dear students? So n minus 3 minus 1. Correct? So this 3 is associated with the third term from the end. And n minus 3 minus 1 is nothing but n minus 2. N minus 2 minus 1 is nothing but n minus 1. N minus 1 minus 1 is nothing but n. Correct? So then, if you look into n minus 3 will be what, dear students? That n minus 4 minus 1. Now this 4 is associated with the fourth term from the end. Correct? So now what we see, dear students, if we proceed like this, then what we are going to get? We are going to get that the rth term. So what we write here, so let me use this one. Okay, so if we see this one is the first term from the end. This is second term from the end. Correct? This is third term from the end. Okay, this is fourth term from the end. Now, as I was telling a minute back, that this 1 is associated with first. This 2 is associated with second. This 3 is associated with third. This 4th is associated with 4. So in that way, if we proceed, what we can write? The rth term from the end, it should be n minus r minus 1 here. Let me write it down. Okay, so the rth term, so if we follow this pattern, dear students, so what we get? The rth term from the end, it should be nc n minus r minus 1 into x to the power n minus, okay, let me write little this portion, so that let me write it here. And okay, so this is equal to nc n minus r minus 1 into x to the power n minus r minus 1 into a to the power n minus r minus 1. Correct? So if we follow this, then if we simplify, then what we are going to get? This is equal to nc n minus r minus 1, that means n minus r plus 1. Correct or not? Into x to the power n minus n will get cancelled, then minus and minus become plus, so it is x to the power r minus 1 into a to the power n minus r plus 1, n minus r plus 1. Now dear students, we got the answer. So this is the rth term from the end. Correct? Now from here also we can generate another pattern. What is that pattern? We know, dear students, that what is the r plus 1th term from the beginning? If you recall, we generally denoted, it is generally denoted by t r plus 1, that is r plus 1th term from the beginning. That is equal to what? That is equal to ncr into, in context to this one, x to the power x plus a power n, x to the power n minus r into a to the power r. So now if we match these two pattern, so what we can get? that this term is nothing but n minus r plus 2th term from the beginning. Because you see, when it is r plus 1, it is r. So here it is n minus r plus 1. So obviously it has to be t n minus r plus 2. Okay. So what we get, dear students? The rth term from the end. So I can write it here. The rth term from the end, rth term from the end is equal to n minus r plus 2th term from the beginning. Okay. In general, if you get a expression something like that, a plus b power n, in that expression the rth term from the end is equal to n minus r plus 2th term from the beginning. Okay. So we understood in a step by step manner how it is. So now let's proceed to the next question. Okay. So now let me write down the next question first. And as I always say, dear students, that you also do along with me. Write down the question the way I am writing. Okay, and start solving it. If something is not clear, pause the video, look it multiple times. Still, if it is not clear, do contact us, and things will be perfectly fine. Okay. So next question, I am going to write it here. The question is, let me take it from my notebook. The question here is that find the term independent of x, independent of x in the expansion of cube root of x plus 1 by 2 into cube root of x power 18, where x is greater than 0. Let us understand the initial condition also. Okay, why x is greater than 0? Because if x is equal to 0, then 1 by 2 into cube root of x, that will become 0. Something by 0 is undefined, so the question will not make sense. If x is less than 0, then if you see that cube root of a negative number, that will give you a complex number, and which is not in context to the question. So that is why x is greater than 0. So how to approach this question? So dear students, that let us assume that r plus 1th term be the term which is independent of x. So then what we can write? We can write t r plus 1 something like this. T r plus 1 is equal to NCR generally, but in this case n is 18. So it is 18 CR into cube root of x power 18 minus r into 1 by 2 into cube root of x power r. Correct. Now if this term, whatever you see, is independent of x, how we can say it is independent of x? So we will get x power something. That x power something, that something we will equate to 0. Then finally we will get x power 0. X power 0 is 1. So finally the term will be independent of x. So that should be our approach. Our approach should be to express this entire term in such a manner that we make it into the some term which is independent of x and a term which is x power something. Okay, so let's do this thing. So if we approach, just a second, if we approach like this, then what we are going to get? So this is equal to 18CR into 1 by 2 to the power r. So these two terms we keep it here because this is completely independent of x from the beginning. Into here we get cube root of x power 18 minus r. Cube root of x means what, dear students? X to the power 1 by 3. That means x to the power 1 by 3 power 18 minus r. That means x to the power 18 minus r divided by 3. Fundamentals of laws of indices. Here 1 by cube root of x power r. That means 1 by x to the power 1 by 3 power r. That means 1 by x to the power r by 3. And that 1 by x to the power r by 3, if we make it into the numerator, so it will become x to the power minus r by 3. Correct, dear students? Okay, so now what we are going to get? So this is equal to 18CR into 1 by 2 to the power r into x to the power 18 minus r by 3 minus r by 3. Using the laws of indices, we know a to the power m into a to the power n is equal to a to the power m plus n. So same concept here, x to the power 18 minus r by 3 into x to the power minus r by 3 will become x to the power 18 minus r by 3, because denominator 3 is common, na? So 3. So we get 18 minus r, that means 18 minus 2r. Now as I was telling few minutes back, dear students, that this entire term, okay, has to be independent of x. Now how we can make it? We can only make it is independent of x if we make this is equal to 0. Then it will become x power 0. X power 0 is 1. So finally the term will be independent of x. How to achieve that one? So if we need to make that this is equal to 0, that means what? 18 minus 2r divided by 3 is equal to 0. This implies 2r is equal to 18. So this implies r is equal to 9. So the moment we get the value of r is equal to 9, now it is easier for us to find the term which is independent of x. And what is that, dear students? So here we are going to apply the value of r equal to 9. So 18C9 into 1 by 2 to the power 9. So this is the term, okay, independent of x, okay. And by the way, though it is not asked in the question, this is the 10th term, okay. Okay, so this is the term independent of x. So I hope you got a very clear idea. So with this note, let me conclude the session here. In the next class, I will again discuss 2 questions, and finally I will make a playlist, and if you start following the playlist from the beginning till the end, you will have a very fantastic understanding about the fundamentals of binomial theorem. Once it is done, then I will go with advanced level of discussions, and that I will do with all the topics of mathematics, all the chapters of mathematics. Thank you very much. Bye.